Sorry, we had not met a co-host, but now she is.
Okay.
Good morning, everyone. I hope you can see my screen. First, I'd like to thank the organizers organized these seminar meetings. And today I'm going to be talking about algebra. First, don't mind the highlighted words, but the first number we have here is x plus 5 into brackets, then into brackets again, x plus 4. Now, this is what we call double brackets. So we are going to expand these double brackets. For a number like this one, we can see the first bracket and the second bracket. So our main aim in such a number is to first look at the second bracket, because normally when you have a number, like if you can see where my laser is pointing right here, x into brackets x plus 4, you normally multiply what's on the right side by what's on the left side by what's on the right side. So that's the same thing you do when it comes to such a number. You look at the numbers that are on this side, on the left side, the first digits you see, and then multiply both these digits by the one in the second bracket. So what you shall first do is you get x by itself. This first x, since it's a positive, we leave it as a positive even right here. So we put this x multiplying the entire second bracket. So we put the x into brackets, x plus 4. It has to multiply all this here. Then we move on to this 5. Remember that the 5 is a positive. It moves with its sign. So plus 5 into brackets, multiplying this at the same time. That way we have got both these digits to multiply those that are on the right side. So when you look at a number such like this, since we know that when you see a bracket right next to a number, you have to multiply. So you multiply x times x, giving you x to power 2. Now, such numbers confuse people because, like, if you can see right on this side of my screen in a black pen, when you have x plus x, your answer is 2x. But if you're multiplying x times x, it will give you x squared, because these x are to power 1, because any number to power 1 is the number itself. So if you have numbers of the same base, it's 1 and 1. Therefore, you write the base itself again as x and add that 1, which they didn't show there. But that's not what I'm concentrating on today. So x times x is x squared, and then this x also multiplies this 4 to give you 4x. And then you move on to this 5 into brackets x plus 4. An easier way is to first write them differently here and then transfer them here. So this 5 multiplies this x and multiplies this 4. So a 5 times x will give you 5x, like that we wrote here, and then 5 times 4. Remember, it's a positive 4, so we leave it as plus 20. So 5 times x is 5x, and 5 times 4 is 20. So as we can see here, we have x squared plus 4x plus 5x plus 20. We have to make sure that these numbers are all collected in like terms. The x squared is by itself, and then the digits that have x next to them are by themselves, and then this 20 that has nothing, we leave it the way it is. So it will be x squared plus, you get this 4x plus 5x. Since they're together, you can add them to get 9x, because 5 plus 4 is 9, and then you just add the x. So it's equals to x squared plus 9x equals 20, just like we had this one here. Moving on to the next number, it's just the same thing we did as the first one. X multiplies everything that's here, and then -5. A number always has to move with its the symbol behind it if it's a plus or a negative. So x multiplies x plus 3, and then negative 5 multiplies also this x plus 3. So x into brackets x plus 3, like that we did the other one, and then negative 5 into brackets x plus 3. Then x times x is x squared, x times 3 is 3x. Now when we come here to negative 5 times x, we always remember that a number always moves with its sign. It always moves with its sign. So since this x is a positive in the bracket and the 5 is a negative times a positive, which is negative 5 times positive x, always gives you a negative. That's when you're multiplying. So it's minus 5x. And then you do the same as here. Negative 5 times positive 3 still gives you a negative. So you put minus 5 times 3, which is 15. Then you get x squared plus 3x minus 5x minus 15. So when you move to this, okay, they're now in their, we have collected like terms, since x squared is by itself, the digits with x are by itself, and the 15 that's alone is also by itself. So you look at these two numbers, you see this is positive 3x. Normally in math, in case 3x was the one starting, we wouldn't put a positive. Like the way you see this x squared, they didn't put a positive because it's a number without a digit in front of it. When it's starting an equation is a positive. So that we put our 3x by itself here minus 5x. First ignore the rest of this so that we can calculate what we get here. So 3x minus 5x. So the way we do this number, there are many ways people just calculate it right away, but an easier way is to first put the bigger number in front of the small number and first change it a bit. 5x minus 3x. So here it's easy for you to get, you just know 5 minus 3 is 2, and then you add the x at the end. But if you're doing a method just like this one, you always have to remember, you always have to remember that the answer you get must have the sign of this biggest number, which is negative 5x. So if the bigger number, which was 5x, had a negative at the beginning before you change it here, you must make sure your 2 is a negative 2x. So when you transfer it back, it will be x squared minus 2x minus 15. The 15 didn't have any other like terms, so we just leave it the way it is. So it's x squared minus 2 squared minus 15. Then moving on to the next number. Yeah. P plus 5 into brackets, and then they put a squared. Now, normally when they put a number like this, it's to confuse students because they don't know what exactly they're doing. But when you put a squared, it means you multiplied this by 2. Like the way we saw this example, x times x gives you x squared. By getting this x squared, you had to multiply x 2 times. So that's the same way we do this number. P plus 5 squared is the same as saying p plus 5, and then you have to put another p plus 5, but you make sure it's in brackets because we are multiplying. I think that's okay. And then the order is the same. P multiplies p plus 5 and 5 multiplies p plus 5. Such numbers are very common just to confuse students, but all you have to do is put another bracket of p plus 5. So the same thing we have here, p squared, because p times p is p squared. P times 5, remember it has to multiply everything here, is 5p. And then you move on to here, remember the 5 is a positive, moves on with its sign. So plus 5 into p plus 5, we do the same. 5 times p, 5p, 5 times positive 5 times positive 5 remains 25, because it's like saying 5 times 5, which is 25 with also its positive sign. There's also another thing when you're multiplying letters with numbers, it's just a confusing thing, but if you have 5 times p, all you have to do is add the p after the 5, which is 5p. So we get p squared from here plus 5p plus 5p from this side plus 25. So our p squared plus, you look at, remember these ones are like times, they always have to be like times. So 5p plus 5p gives you 10p. Since they are both positives, it's not a hard thing. All you have to say is 5p plus 5p. 5 plus 5 is 10, and then add the p at the end, which is p squared plus 10p plus 25. You leave that 25 alone because it doesn't have any other term that looks like it. Then moving on to the last number, we have s minus b into brackets a plus b. Now for this number, it's also the same. A multiplies this, and then negative b, never forget the sign. Negative b also multiplies everything that's inside here. So a times a is s squared. Never forget, always remember a number, if it's a letter a times a, always gives you s squared, because these a's have an exponent of 1 on them, but we don't show them. So all you have to do is put the a there, add these ones to get a 2. So s squared plus a times b gives you ab. You just have to add the b next to the a, then minus b times a. Remember, negative times a positive gives you a negative, so it's negative minus ab. Then a negative times a positive, negative b times positive b also gives you a negative, so it's negative b squared. Remember, after saying negative times positive is negative, we have now done that. Then b times b is b squared, just like this a was a squared. So you put negative b squared. So if you look at a number now, come down here, AB, which is a positive there, minus AB. These numbers aren't, okay, they look difficult, but they are not as difficult as that. An easier way is that first imagine this AB was a 4, and this was also a 4. So positive 4 minus 4 is the same as saying 4 minus 4 equals to 0. You have 4 oranges, take away 4 oranges, you're left with nothing. So it's the same as AB. If it's letters or numbers, if that letter AB is being subtracted from AB, you get a 0. So AB minus AB, because okay, you have your AB here and you're subtracting AB. So if you have AB and you're subtracting AB again, you're left with nothing, which is a 0. So we don't write the 0 here. All you say is s squared minus b squared. This is our last number. But for numbers that appear like this, it's difference of 2 squares. Squares means a number has an exponent of 2 upon it. It was multiplied twice. For numbers like this, and if they are to tell you this time, not expanding it from double brackets to just this, if they give you a number that's in the question, it's like this, s squared minus b squared, and they want you to put it in form of double brackets, and the answer is always the same. It will be a minus b close brackets into another brackets, a plus b. That's how we do difference of squares. If you see numbers that are squared together and you're asked to put them into a double brackets, all you have to do is a minus b into a plus b, because the number will always get you back to s squared minus b squared. Because now imagine this is a times a, remember you multiply this times what's here, so that a times a will give you a squared, and then a times b will give you ab. Please excuse my handwriting. Then negative b times a gives you minus ab. Remember, you just add the number next to it, and then negative b times b gives you negative b squared. So you see, what exactly we have here is what we had here. S squared plus ab minus b squared, which will take you back into this. So in case you're given difference of 2 squares, s squared minus b squared, your answer will always be this. And also, if you're given it already in this format, you know that if it's saying a minus b and a plus b, the numbers must be the same in both brackets. Let's say this one is a negative and then this one is a positive. And you have to make sure that your answer is always in squares, because that's the way of proving your answer is right. But my main focus today was to teach you from double brackets to just a normal digit, taking it out of double brackets. So anyone who has a question, I invite your questions.
In case you have a question for Blessed, you can raise your hand. Okay, Daphne.
My question is that she said that, okay, s squared is equal to b squared. So like if they tell you to represent in double brackets, how do you know that the first one is minus and the second one is plus?
For such a number like that, in case it's given, you're saying in case it's given to you like this, a squared minus b squared.
Yeah.
Okay. Mathematically, okay, people know that if a number is given to you like this in squares, it's supposed to be like this. But to be on a safer side, you need to work it. Let me first work it. Okay, s squared minus b squared is just like this. So minus wait. Okay. Okay, my main focus, okay, I'm not going to show you exactly how to do it, but I'm going to tell you how it ends up getting a minus b into a plus b. When you look at, I'm going to just show you proof that it gets you back to this. So when you look at a number like a squared minus b squared, we say that, okay, I've seen that we have worked out this one and we have ended up with this. So in case you have a number like this, to prove that it can go back to the way it was, an easier way is to first say, okay, since I've learned the trick that it will give you a minus b into a plus b, first write it there, a minus b into a plus b, the way it is here in the question. And then say, okay, let me first work this thing out and find out if truly what they said is right. When I calculate this as a double bracket, shall I get this as my answer? So when you look at a minus b into a plus b, you've seen how we've worked it out all the way till down here. You find that when you multiply a times all this and then negative b times all this, you get this as your final answer. Yeah. You get this as your final answer. And then you know that this AB, once you get AB minus AB, you're left with 0. So it's a squared minus b squared. The easiest way you can do it, sometimes in an exam, they can tell you write a squared minus b squared in form of a double bracket. Now, if sometimes they give you it as 1 mark, you can write it as this, but in case it's given as 2 marks, an easier way is to do this. Okay, you get, please excuse my handwriting, a times a times negative b. Remember that b has to always move with its sign. Sorry, wait. The b has to move with its sign. Times b, then times negative b. The reason why I've left,
I think let's just hold it. Let's get teacher Gorete who wants to help out here. Teacher Gorete.
Thank you, Mr. Dungu. Thank you, Mr. Dungu. I just want to communicate to everyone who is here that one is one of the 3 identities that we have. So Blessed may not be in position to explain that. She has actually showed it, that when you multiply those 2 brackets, you come up with this. And it's one of the identities which we call a difference of two squares, because we have a squared down. When you look at Blessed's work at the bottom, we have a squared minus b squared. That means we are subtracting two squares. That is why it is called a difference of two squares. And it can also be written as a minus b into a plus b. So there is not much explanation there. We've ably seen that when you multiply those two brackets, you get the difference of two squares. Blessed can't do anything more than that.
Thank you, madam.
Okay, thank you, teacher. You cannot do the reverse. You may not come from a squared minus b squared backwards, but you can come from up. So maybe Blessed, can you use that same identity to solve 9 squared minus 4 squared? How do I use the other two brackets to solve 9 squared minus 4 squared? Blessed, are we losing you? Or is it me?
Squared. No, I'm still on.
Okay, go ahead.
Just like the teacher said, there's not much into converting it from this squared back into this. So all you have to do, just like the teacher said, that there's not much into changing it from here, going back to double brackets, but there's much into converting it from double brackets back to this. So your answer, remember, as long as you see two squares, as long as you see two squares together, automatically you have to know it's going to be 9 minus 4. You have to eliminate the squares when writing your answer. Into 9 plus, into 9 plus 4. Because, okay, mathematically it's supposed to be written like this. Because when you multiply this 9 times what's here and this negative 4 times what's here, you get 9 squared. I want you to see this. 9 times 9 equals 9 squared. And then this 9 multiplied by this 4 will give you 36. And then come to this negative 4 times 9 gives you minus 4 times 9, which is 36. And then negative 4 times 4 will give you a minus 16. Oh, okay, let me just let me write it in a proper way. When you get, coming back to the first one, and you get this 9 times 9, it will give you, 9 times 9 is 81. Let's first leave it like that. So when you see this 36 minus 36 gives you a 0. So all this here is turned into a 0, because 36 minus 36 gives you a 0. So you don't need to write it there. So you're left with 81 minus 16. This, we are proving our answer right. So if you really look at these numbers, 81 minus 16, these numbers are in a square form. But the way we got 81 is we multiplied 9 twice. So 81 is the same as saying 9 squared, because then 9 times 9 gives you 81, minus 16. When you get the square root of 16, you get 4, because 4 squared. So because 9 times 9 will give you 81, and then minus 4 times 4 will give you 16. So that's how we prove that this method of math of double squares is as double squares will always give you the number like this, the number minus a minus b into a plus b. The way I've calculated it here is the same way you can. So even if they give you 9 squared minus 4 squared, it will always lead back to what we had here. It will always lead back to what we had here. Because the 81 is the same as saying 9 times 9. So just put it as 9 squared minus 4 times 4 squared, which is 4 times 4, gives you 16. So that's how we prove that this mathematical concept is correct. Difference of two squares, not addition of two squares. Addition of two squares is something different. Difference as in minus. Difference of two squares will always lead you to an answer like this one.
Blessed, can you go on and complete this number of 9 minus 4, 9 plus 4? Can you go on and calculate for them and complete it?
This one that I've just written now, the double brackets I've just written.
Okay.
Yes. That.
Okay. As we had said, as we are calculating the previous numbers, what's in this first bracket multiplies everything here. So 9 into 9.
Blessed?
Yes.
So Blessed.
Could you just subtract them directly, say 9 minus 4 and get the answer, then 9 plus 4 like that?
Okay. Okay, so if we directly subtract 9 minus 4. Stefan, is that what you are saying? I directly subtract.
Yes, like you want to apply that identity directly.
Okay, so 9 minus 4, we all know that it's 5. And then open inside brackets, 9 plus 4 is 13. So this is the same as saying 5 times 13, because brackets means you multiply. So 5 times 13 if you get this 5 times 13, this is 15, you get 65. So, okay, after getting a number like this one, you have to also make sure that it's also correct. So when you get, you look at this number that we had right here, 9 squared minus 4 squared. Get 9 times 9, which is 81. And then also get sorry, please fast forward as I wrap this.
Mr. Kaziva, I think we need to continue because we want to see whether 81 minus 16 is also equal to 65, isn't it? That's what we are looking for, Blessed. So the question is, how does the identity help us to answer questions easily? 81 minus 16 is 65. 65 can also be obtained from 5 times 13. That is why we learn these identities. But I know that the teachers have not reached this far. We closed schools, but these are some of the areas we are going to handle going forward.
Thank you so much, Blessed Cooper, for the presentation. Those who still have questions, you can type them in the chat. She's going to be able to answer them, and we shall allow you to ask at a later time. Thank you so much, Blessed. So she has done a few of the numbers on number 20 when you check our seminar questions. So the rest of the numbers that we have there, we shall be doing them in our free time. Good enough that now you have understood the concept. So those numbers that have not been touched, please go on and use the same approach she has used, such that you can be able to expand the brackets and also to go further and learn how to use the difference of two squares. We are going to have one more presentation.
Mr. Kaziba, can we allow?
Yes.
Can we allow Mr. Abraham? He has his hand up.
Okay.
Thank you so much. Can you hear me?
Yes, you can go on, Mr. Abraham.
Yes, Stephen, I was trying to let students know we may be presenting the mathematics, but we have to present the math well. Now, like the recent presenter, she has no equal sign. But she always put equal sign to give direction for our answers. It's not just a matter of writing stuff and then going on like that. That's my input. We should always give direction for our answers, so the one who's going to look through our work doesn't get confused. Thank you.
Okay, thank you, Teacher Abraham. And I'm happy that the presentations are improving. Of course, technology is one key thing we are learning. And I hope in the next presentations, we shall do better. There is also another hand, Queen Fifi. Mr. Abraham, mute yourself. Queen Fifi, is that hand up? Okay, Mr. Kaziba, I think we'll continue to the next presenter.
Okay. Do we have, is Georgina around? Georgina, you're our next presenter. Georgina, are you on the call? You can raise up the hand in case you have not yet gotten the co-host rights. Georgina, you can raise up the hand. Okay. Yes, Mr. Ronald, you can give Georgina co-rights.
Mr. Kaziba, there are senior 3 students already on this call, and they're asking me the link that will take them to the senior 3 class. This is the senior 3 class when it comes to 11:30. Now it's an S2 class because it's still S2 classroom. This is a main hall where the teachers were here from 8 to 10. The senior 2s are here from 10 to 11:30. The senior 3s will be here 11:30 to 1. And next week, the 5s will come in from 2 onwards, shifts. Those who did not get the questions, I'm going to post both the senior 3 and S2 questions in the chat room. Over.
Mr. Ronald, can you give Georgina the co-host? Mirembe Georgina Iga.
Yes, I think I have done so.
Okay, thank you. So Georgina, go on.
Yes, good morning to you all. My name is Miriam Georgina, and I'm discussing number 16, which says writing solution sets for the following numbers. So our first number is this, and we are going to read it as x is less than 0. So if we are to write the solution set for this statement here, for the inequality here, our solution set will comprise of numbers that are less than 0 because of this symbol here, which is a less than. So our solution set will be stated as x is equal to the numbers that are less than 0, which are -1, -2, -3, -4, and so on, which we are summarizing. Okay, like there are very many numbers that are less than 0, but we can't write all of them because there are so many. So we shall summarize them with just these 3 dots, and we shall close the curly brackets. So we come to B, the inequality. We are going to read it as x is less than or equal to 5. So for the inequalities of this solution set here, we shall include 5 in the solution set because of this symbol here, which is read as less than or equal to. It means that 5 is going to be part of our solution set. So our solution set will be stated as x is equal to 5 because of the symbol here. Then also the numbers that are less than 5, yeah, so it will be 5, 4, 3, 2, 1, and so on, because there are very many numbers that are less than 5, but we can't write all of them. So we shall just summarize them with these 3 dots, and then we shall close the curly brackets. So moving to the third number, we have x is greater than or equal to -2. As I've explained in B, since there is a bar down here, since our symbol in between x and the -2 has a bar, we are going to include this -2 in our solution set. So our solution set will be stated as -2 because of this symbol here, -2, then -1, 0, 1. Remember, there are very many numbers that are greater than this -2, but we can't write all of them. So we shall just summarize them with these 3 dots to mean that they are still more, but we can't write all of them, and we shall close the curly brackets. So moving on to our next number, we have D, which is read as x is greater than or equal to -2 and less than or equal to 3. Our solution set here will comprise of, we'll have to begin with -2 and then end with this 3. Reason being that we have a bar, like the symbol in between this x here and this -2 has a bar, meaning we have to include the -2 in our solution set. Likewise to this second stage, where the symbol in between this x and this 3 has a bar, meaning that also 3 shall have to be included in the solution set. So we shall state our solution set as -2 because of this symbol down here. Then also the numbers that follow -2, which are -1, then there is a 0, a 1, a 2, and a 3, because the symbol in between the x and 3 has a bar. That's why we are including the 3 as our last integer. Here we are not going to include the what? We are not including the dots because it is a closed set. It has the beginning and the end. Yeah, so we are moving on to the fifth, which is read as y is greater than -5 and less than or equal to 5. Our solution set here, as you see down below, let me help you do this. As you see down below, it's not including the -5. Reason being Reason being that the symbol in between the -5 and the y is not having a bar down. That is why in our solution set, we are not including the -5 there. So our solution set will be written as y is equal to the -4, which comes just after this -5, then the -3, the -2, -1, and the 0, 1, 2, 3, 4, and the 5. We are including the 5 because of this symbol in between the y and the 5. Then we shall close our curly brackets. Moving to the 6th one, which is 4 is less than x. But I think it would make more sense if we read it as x is greater than 4. I think it can make more sense there, and it shall help us like find the answer easily. So here, our solution set will be written as x is equal to the numbers that are greater than 4. Hope I'm clear. So we have the 5 here. We have 6, we have 7, we have 8 and 9, and so on. Because there are very many numbers that are greater than 4, but we can't write all of them here. We're just summarizing them with these 3 dots, and we shall close the curly brackets. Moving to this one, G, we have x is greater than or equal to -3 and less than or equal to 4. Still here, as I said earlier before, that if the symbol in between, for example, as we have x and 3, if the symbol in between these two, the -3 and x, has a bar below, it means our solution set has to start with that very number. I hope I'm clear. So, and same knowledge is going to be applied on this x and on this x and 4. Since the symbol in between both of them has a bar, we are also including 4 in our solution set. So our solution set will be stated as -3 because of this, and then -2, -1, 0, 1, 2, 3, and 4 because of the bar. Yes, hope I'm clear. Then we move to the last one, which is H, and it is read as x is greater than 0 and less than 3. So here, in simplified terms, we are just going to list the values in between this 0 and the 3. Those values are just 1 and 2. I hope I'm clear. Any questions?
In case you have any question, you can raise up the hand. Okay, Moses Sally.
Yes, thank you so much, our coordinator. Yes, I'm a teacher, and I just wanted to ask our presenter if she has come across the difference between a set of integral values and a solution set. Just that, because what I'm seeing, what she's calling a solution set is a set of integral values from that inequality. Then a solution set, I thought it is represented differently. Maybe fellow teachers will come in and rectify that. Yes, that's what I wanted to clarify on.
Mr. Sari, could you mind to go on and clarify?
All right.
I think,
yes, Mr. Dungo.
Mr. Sari, the question integral values.
Yes, Mr. Dungo.
The question mentioned that they needed integral values only.
Oh, so in the language, I think what she was presenting, she needed to stick to integral values rather than solution set. For the solution set, I think it is presented differently from this.
Okay, Mr. Sali, could you just add a little bit about the solution set?
All right, a solution set, when they ask for a solution set, assuming you've worked out your inequality and you have an answer, I'll use a last example. Assuming you worked out an inequality which gives you that solution. X is greater than 0 and less than 3. So a solution set, you would write X is equal to, you open the brackets, you write X again, you put there a semicolon, and then you rewrite the very inequality and you close the brackets. That's what we call a solution set. Then when they ask for a set of integral values, then you write
Have I lost Mr. Sali or it's me?
Yes, Mr. Dungu.
I think I lost you. Maybe I just lost you as we are hearing you.
Okay. Let me explain again. A solution set, you write X is equal to, I'm using a last example. If you worked out an inequality and you ended up with an answer, X is greater than 0 and less than 3. So a solution set would be X is equal to, you open brackets, then you put there X, then a semicolon, then you rewrite the very inequality, and then you close the brackets. That's what we call a solution set. On the screen, I think someone can help me write that. I'll present, I don't know if you have the rights right on the screen so that people can see.
Georgina, can you write?
Yes. Excuse me, sir, can you please help me with what you said last?
Yes, we are writing a solution set for the last example. That is H, example H. So you say X is equal to.
Mr. Kaziba, you could write in the meantime, as because I see that her system is hanging. So if you could share your screen and then do the writing.
Okay. Georgina, could you stop? Okay. Moment. Yes, Mr. Sally?
Yes, X is equal to.
Moment. Yes. X is equal to
open brackets, X, semicolon, that's colon, semicolon. Okay, maybe it's okay. Then you write the very inequality towards X greater than 0. No. X is in the middle, X greater than 0 and then X less than 0. Okay, that's okay. Assuming that is the answer you got after solving an inequality, and then you close the brackets, So that's what we call a solution set. Then what she explained was a set of integral values. Answers to inequalities can be presented in 3 different ways. They can ask for a solution set, they can ask for a set of integral values, or a number line. But that's a solution set.
Okay.
Yes.
Thank you so much, Mr. Sally. Let me hope now.
Thank you, Mr. Sally. Of course, going by the question, it asked for integral values, and that's why she kept listing the integral values. only that maybe we should have written the question as state the integral values in the solution set, not starting with the solution set and then in brackets integral values. So I think her work was okay, but we've also been able to reflect on the fact that a solution set could also be written by restating the inequality statement in the set. And I think we had the first question where the first discussant also brought out the number line, and she was very clear on the number line, how to present work on a number line. Okay, thank you. Mr. Kaziva, do we have a short question we can go in before we go into the next activity? Different from these ones we have seen.
Mr. Ronald, I think let's first go on to that activity, then we can come back in case time allows. But can we first take on the question from Shona?
Yes, I was asking that, let's say in an exam, and they have set a question like that. So do we write, would they describe, would they tell you to write the solution set and then also maybe to write the values, or they won't be specific?
Now, Shona, each question will be specific. If they want a solution set, they will mention it. If they say integral values, they will mention it. And if they say integral values and you leave it in the solution set of x greater than 4, then you don't get the final mark of it.
Okay, thank you.
Peter? Yes, Abraham, before Peter comes.
There's something when they just tell the learner to just solve the inequality. So maybe they just say maybe solve the inequality just have to stop at the answer when you have maybe x greater than 0 or x less than 1. You stop there also.
Okay, I hope, Abraham, you were loud enough because I wasn't hearing you well.
I'm
okay,
saying,
Peter? Yes, Abraham.
Yeah, most times the learner may be required to just solve the inequality. So when you are just required to solve the inequality, you just solve and then you don't go into the start of finding a solution set or putting on the number line, you just stop at solving. And maybe present your answer as maybe x less than 1 or x greater than 5 and just stop there. Then there are no additional questions.
Okay. Okay, thank you, Abraham. Peter?
Mr. Ronald, I was inquiring about the 3 methods of representing your answer of the solution set and the interactive values. It was not very clear to me.
Okay, Peter, in the first question, if you noted, we represented our answers on a number line. So that is one way when they ask you to represent solution set on a number line. The next bit is when they ask you to represent, to give a solution set. And that is what Mr. Sally was talking about. The third is when they tell you to list the integral values. And that is what the discussant was doing. And then the teacher, Mr. Abraham, has also said, they just be solve the inequality, then you just end at x is greater than 4 and underline. You don't go into number line, you don't go into solution set, you don't go into listing integral values, because then you end up failing the question, especially if it said x greater than 4 and you just list integral values, then you leave out the fractional values and you fail. We don't want to give questions to people who don't label their iPhone 11. I'm not going to give you permission because I cannot read your name. Friends, when you go to the participants list and hover, put a cursor on your name, it will tell you rename yourself and write your name there. So Mr.